In this section, we're looking at rational functions. Remember, rational numbers are numbers that can be written as fractions. So here we're looking at f of x, where it's written as a fraction, and really we have a function making up our numerator and a function making up our denominator. Now, anytime we have fractions, one thing we have to watch out for is 0 on the bottom of our fraction. And what happens when we're looking at rational functions is that wherever the denominator is equal to 0, that's where we have our vertical asymptotes. Remember, an asymptote is going to be a line that the graph will approach but does not touch. All right, and so we have vertical asymptotes at the zeros of our denominator, or d of x. Now, a vertical line, remember, as far as how we would write the equation of that line, we've already looked at that. It's going to be written as x equals, and then whatever our value is. Let's say that it's going to be x equals a is going to be where our vertical asymptote takes place. We also will have horizontal asymptotes within rational functions. Now, these occur in different places, and what we want to do to determine where these horizontal asymptotes are is we compare the degrees of our numerator and denominator. So we have the numerator by function n of x and our denominator is function d of x. And when we compare the degrees of those two, that's what's going to help us determine what's going on with those horizontal asymptotes. Now let's say that the degree of our numerator is n and the degree of our denominator is m. So if the numerator is less than the denominator, if the degree of the numerator is less than the degree of the denominator, then that's going to give us a horizontal asymptote at the x-axis. And if the degrees are equal to one another, then we have a horizontal asymptote, and it's going to be at this time we're going to compare the leading coefficients. So it's going to be where y is equal to, and we're looking at the leading coefficients of our numerator and denominator. So a sub n and b sub m would be those leading coefficients. And so when we're looking at that, that's what's going to tell us where that horizontal asymptote will take place. And remember, those are leading coefficients. So the other scenario is that our degree of the numerator is greater than the degree of the denominator, in which case there is no horizontal asymptote. All right. So we're going to look at a couple different scenarios now. Just in general, if I have y equals 1 over x, and if I have a different function f of x is equal to 2x squared over x squared minus 1, what is it that we're going to end up with for graphs? And we're just going to make a quick sketch. What do these graphs look like based on the information we have right now? So because here when I'm looking at this, the degrees are different. For example, this, we have a degree of 0, whereas the bottom is a degree of 1. So that tells me that horizontal asymptote-wise, the denominator has a degree that is greater than the numerator. And so we're going to have a horizontal asymptote, that's our scenario here, where y is equal to 0. So a horizontal asymptote at the x-axis. So over here, that means I'm going to say that we're going to have that horizontal asymptote right across here where y equals 0. I also see that I have a x value on the bottom of my fraction. So remember, as far as those vertical asymptotes, that happens wherever the denominator is 0. This one's pretty easy. That's going to happen where x equals 0. So that's going to give us a vertical asymptote here where x is equal to 0. Now the only thing we really need to pay attention to at this point is when is it positive and when is it negative. Here we've got our asymptotes mapped out. Now if I plug in a negative value for x, I'm going to get a negative value for y. So that's going to end up in quadrant 3. If I plug in a positive for x, it's going to be positive for y. That's in quadrant 1. So because of these asymptotes, then a rough sketch of this graph is going to look like this, where I'm going to have the values, everything in the third quadrant, everything in the first quadrant, and approaching but never touching the x and y axis. Now over here we have f of x equals 2x squared over x squared minus 1. If I think of the factors of this, that's the difference of squares, that's x minus 1 and x plus 1. That tells us then that we're going to have vertical asymptotes where x equals 1 and negative 1. So that means I'm going to have a vertical asymptote here where x equals negative 1 and a vertical asymptote here where x equals positive 1. Now we also see that the degrees are the same. So when the degrees are equal, now we look at our leading coefficients to find out where our horizontal asymptote is going to be. In this case, leading coefficient here is 2, here it's 1. So we're going to have a horizontal asymptote where y equals 2. So I'm going to sketch that across here. There's my horizontal asymptote where y equals 2. Now the only thing we need to pay attention to at this point is what's going to happen, where could I get negative numbers? I see both of these are x squared, so whatever I plug in for x is going to be positive. But if I have an x squared minus 1 on the bottom, if this value is in between negative 1 and 1, that's when I could end up with a negative because I'm going to have a small number and I'm going to subtract 1 from it. So what that's going to look like is, it's almost like a parabola here. I do know that if I plug in 0 for x, I'm going to end up with 0 on the top, so I would end up with 0 for y. So I know it's going to go through that point, and otherwise it's going to come up, down, and again, kind of like a parabola, except we have these vertical asymptotes. Otherwise, when I plug in negatives for x, they get squared, so it's a positive number. And if I obviously plug in a positive, it's going to stay positive. So the rest of this is going to look like that. Here's some steps we went through when we were sketching those graphs. First of all, we simplified them if possible. For example, on that second example, we factored the denominator. That helped us then in finding asymptotes, and that helped us sketch out that graph. If you can find intercepts, then that's the next piece as far as sketching a graph. And then from there, thinking about positive and negative values and where those would lie. If it helps, you can make a table and plot some of those points. But these are some quick steps we can go through when sketching a graph to get an idea of what that function is going to look like. Now I want you to use those steps for sketching a graph and to go through and sketch this one. Here we have f of x equals 3x over x squared plus x minus 2. And use those steps to sketch yourself a graph. Pause the video, go through that, and then I will show you what it looks like next. Okay, so here first off I simplified and factored the denominator. That's going to help us find those vertical asymptotes. And so if I plug in negative 2 here, that gets me to a 0, so that's a vertical asymptote. And if I plug in a 1 here, that goes to 0. So there's our two vertical asymptotes based on the denominator. Our horizontal asymptote, remember, is based on the degrees. First of all, the numerator has a degree of 1, denominator has a degree of 2. So then that tells us that we're going to have a horizontal asymptote where y equals 0. Now this one's interesting because in between these values, this line does cross the x-axis, because if I plug in 0 for x, I end up with 0 over negative 2. And so in between here, it does cross through the origin. However, in these other parts here, this is where we're going to have that horizontal asymptote, and what we're talking about is as it's approaching negative infinity or positive infinity for x. And then the next part, I just mentioned that the intercepts at 0, 0, found that when I was plugging in some points. what I did as far as plugging in points, because I knew where my asymptotes were, I picked -4 because that's on this side of this vertical asymptote, and it'll kind of give me an idea where those points are going to fall. And then I picked -1 and 0 because that's in between these two, and then I picked the number 2 because that's on the other side of this vertical asymptote. So as I plot those points, if I'm at -4 for x, I was at a -1.2 value for y. And I plug in a -1 for x, I was at a +1.5 for y. I already have the 0, 0 marked there for that point, and then as I go past this vertical asymptote, if I plug in 2 for x, I get 1.5 for y. That is up here. And so that gives us an idea, just those few points, because of where those asymptotes are, what this graph is going to look like. This is going to come across here, that's going to go forever that direction, that's going to go forever here. This one, we are going to come across here. It actually crosses at that point and then continues down that way. And then here we're coming through this way, and then we've got our asymptote there at the x-axis, and it's going up that one. We also could have a slant asymptote, and if the degree of the numerator is exactly 1 more than the degree of the denominator, that's when you will have a slant asymptote. And we'll use long division to find the equation of that slant asymptote. So in this example, we have our function 3x squared plus 1 over x. We can see that the numerator has a degree of 2, denominator has a degree of 1. So we're still going to go through this the same way. We're going to find our vertical asymptotes, see if there's any horizontal, find any intercepts, try and sketch ourselves a graph, and do the long division to find the equation of our slant asymptote. So start going through some of those steps, and then I will show you how to do this. With the long division, I'm going to find out x. What do I multiply by to get 3x squared? So if I multiply by 3x times x is 3x squared. And then that goes to 0. And as far as the x going into a 0x, that would stay 0. So what we end up with, if I multiply by 0, we're getting 1. We end up with a remainder, but what we're really looking for is this part right here, because what we have just found is that our equation for that slant asymptote is going to be y equals 3x. And so when we graph that, it's just going to be a line. It's linear, has a slope of 3, and so I can just sketch that in there. We're going to have a slant asymptote coming across there that direction. Now, we also know that our vertical asymptote is where x equals 0. Remember, what we're looking at there is our denominator. When that denominator is 0, that's what gives us our vertical asymptote. And because our degree for our numerator is greater than the degree for our denominator, there is no horizontal asymptote. I also started to make a table here. If I set the numerator, 3x squared plus 1 equal to 0 and solve, I end up with the square root of a negative number. So there's no intercepts and no x or y intercepts. So as I start to sketch these points when I'm graphing this, I have a -2 and a -6.5. That's going to give me a point over here somewhere. And then we have a -1 and a -4. That's still going to be in this range somewhere. And remember, we also said that it's going to have that vertical asymptote where x equals 0. So this graph is going to come up through here and then right back down the x-axis. Y-axis, excuse me. Same idea then for our positive values. When I'm plugging in a +1, I get a +4. That's going to be over here. And for the 2, it's 6.5. So again, it's coming from this direction, turning and heading up that slant asymptote. And that's how we can kind of sketch through that graph. Again, just picking points that are close to figure out what part, how those asymptotes are going to dictate what this graph looks like.